Towards accelerating the European Union's energy transition. This is, of course, a great debate in the context of the need for EU to boost its strategic energy autonomy, moreover to promote the use of energy produced from renewable sources. Today's event is co-hosted by MEPs Ms. Maria da Graça Carvalho and Mr. Christoph Grudler, so thank you very much once again for taking the lead. Just before we kickstart the event, I would like to provide some housekeeping rules for the audience. So we're in the European Parliament in Strasbourg. We have some speakers in the room and viewers as well, also connected online. The event is recorded, so the recording will be made available on the website of the European Parliament Intergroup the day following the event. The presentations as well, available at the ABCD website as of tomorrow. And then last but not least, for our audience, just a small reminder, as we want to have the discussions as interactive as possible, participants can send us your questions via the Q&A box of the platform that should appear at the right-hand side of your screen. Once again, I'm delighted to welcome you today, and with no further ado, I'll be providing the floor to hosting MEPs for their official opening remarks. So perhaps we can start with MEP Ms. Carvalho, followed by Mr. Grudler.
Thank you, Elias. I'm delighted to be here today with you and to organize and to co-host this event with my colleague, Mr. Grudler, and also with the intergroup on biodiversity, climate change and sustainable development, that I'm part of this very active and very successful intergroup. And I would like to thank Elias and all the intergroup and everyone that has worked to the organization of this event. And I'm delighted because it's the first time that I organize with Mr. Grudler. Is a pleasure. We appreciate very much your interventions and work on ITRA, but we never had the opportunity to organize something together. And I'm also delighted because we are talking today about research and innovation and energy, that are the two topics of my preference. I'm a professional. I'm a mechanical engineer, university professor in energy, exactly, in mechanical engineer, but in energy, from University of Lisbon, where we have a large group on many areas from renewable energy to ocean energy, very much on novel, and we look for novel ways of energy. And we are dealing here today with solutions for the biggest challenge that I consider that we have in front of us. In order to have energy that is clean, that is affordable and available for all of us, is one of the biggest challenges. And if until now was very important for the climate, environment, and for the economy, now has a third component. It's very important for our peace in Europe. We need really to solve the question of energy. And in my opinion, and based on the principles of thermodynamics, on the physics, on the chemistry, we have not explored all the potential that we have in front of us. And there are sometimes simple principles in physics or in chemistry that we are not paying enough attention. And this is the case of osmotic energy. That is a very good example of something that we have not explored enough. We're taking advantage of the difference of salinity of cold water and salted water when rivers and seas meet together. So something that is simple, very well understood for the ones that are not engineers or from physics, but for reasons that probably is not the point to explain here, we have not explored these kind of solutions. And there are other solutions that we really need to look at it, that we need to scale up, that we need to make to enter to the market, because the solution for clean, affordable energy for all is still not on the market. We do not have the solution yet, because the solution that we have been based until now has been very much based on a fossil fuel economy that is not now, we cannot continue on that because of climate and environmental issues, because air pollution is also a very important topic that we forgot many times, very bad for health. And but now also because our survival in terms of strategy in Europe. So I'm saying it's not the only solution. There are other solutions that we need to continue to like the small nuclear power plants, smaller dimension. My university have also looked at the OTEC that explores the difference in temperature in the sea. So many areas that we really need to explore, and today we are looking to a very interesting solution. But we have been focused in Europe very much on regulation, and we are now, most of our time is to set up the most ambitious regulation in the world in terms of ambition targets for energy and climate change. However, we do not have the same ambitions on developing research, innovation, technology that will match these targets, and we really need to do that. Otherwise, we will have very ambitious regulation and non-technological solutions to meet these targets. And if we do not have these technological solutions, the only possibility to meet these targets is completely change our lifestyle. And the Europeans are not prepared to change completely lifestyle, do not have warm houses, do not travel. So, okay, we need to moderate, no doubts, but to change completely, we are not prepared to that, because our life, everything from the computers that we use, from the medical devices that we require when we are not in good health, they really require a lot of energy. So we need to invest more in research and innovation. We need to invest more on scaling up, pilot scale, demonstration, early entrance to the market of these new ideas and new technology. And some of them are not so new, but they have not been the push to develop. So you have all my support, and as you have been very much involved in the research files. I was in the past one of the rapporteurs of Horizon 2020. This time I have been rapporteur of the public-private partnerships that include, for example, the bioenergy and the hydrogen. I always push for more funding for research and innovation, more funding for new ideas, not only the conventional ideas. We need to be open to new ideas, and you can continue to count on me to support research and innovation, breakthrough ideas, and scale up of existing ones, so that we have solutions, technological solutions for our problems. So thank you for your being here, for the speakers. And unfortunately, I cannot stay all the time, but I will look at this from political point of view, but also from my researcher professional point of view with a lot of interest. Thank you, and Mr. Gruber.
Thank you very much, dear colleagues, dear Maya da Gracia. It's a pleasure to co-host this event with you for the first time. Dear panelists, dear all, I would like to thank you for joining us today in Strasbourg to exchange on osmotic energy. It's a real pleasure to organize this event with MEP Carvalho and the Intergroup. I will enable us to fully the meaning and the challenge of the innovative renewable technology with EU's top experts. In the context of the climate transition, the deployment of renewable energies is no longer an option or a political opinion, but a must to reach our neutrality objectives by 2050. When we think about the decarbonization of our economy in a cost-effective way, direct electrification comes first. As for the hard-to-abate sectors, we need to deploy a full-fledged clean hydrogen market, for example, including electrolytic renewable hydrogen. Solar, wind, or even biomass, these are sources that are fully acknowledged and included in our political debates to make this happen. But these are the existing technologies. But Europe has huge potential to bring out new future-proof technologies, but it's water, yeah. And osmotic energy is the perfect case. Energy is and will be the issue for the months, years, and decades to come, as it determines all aspects of our society. More specifically, for hydrogen, the Repower EU plan has set a target of 10 million tons of domestic renewable hydrogen production and 10 million tons of renewable hydrogen imports by 2030. I strongly personally believe that importing 10 million tons is and will be harmful to our strategic autonomy. But we have to choose our priorities. Mine is to support our domestic market and its actors. Osmotic energy is one of the most promising energies of the years to come, and one in which we must invest. It is domestic energy, and it is good for strategic autonomy. Europe has the right geographical diversity for such energy. We have seas, we have oceans, numerous rivers and estuaries. We must make the most of our resources. This would also allow us to light and heat our homes without financing any despotic regime. First, as French, I am proud of the groups and SMEs that work on making our energy system as initiative and clean as possible. I am thinking, for instance, of EDF on Switch Energy that are present today, who signed a collaboration on the deployment of osmotic projects. And as European, I would like the Union to become the leader in the innovative ocean renewable energy, including osmotic. And finally, as Shadow Rapporteur for Renew Europe for the revision of the Renewable Energy Directive, called RED 2 or 3 now, in a few years, in a few months, no, years, I hope so. I fight for the increasing role of innovative technologies to participate in the achievement of the overall target. Today, I have the great pleasure to inform you a target for innovative technologies has been included in the compromises ahead of the committee vote. We will vote on the 13th of July. And inside, you have also a definition of osmotic energy included as a renewable energy. Alongside the political support, we need a sound EU regulatory framework, including definitions on targets, and a strong financial support for the public and the private sector. Let's work all together to make this happen. The future is, of course, when the sun shines, is, of course, when the wind blows, but it is also when the water flows. I'm looking forward to hearing you, your point of view and your experience on this topic. Thank you very much.
Thank you very much to MEPs Ms. Carvalho and Mr. Grudler for setting the scene with regards to the discussion to follow, and specifically for underlining the key importance, but also the timely nature of having this discussion today. Looking into the untapped but also significant potential of osmotic energy. Inter alia, MEPs highlighted, of course, the great role of science and technology, research and innovation, scaling up solutions and funding new opportunities, as well as the need for support for the domestic market and its actors. Moving ahead into the discussion today, I'll be giving a fresh plot twist with regards to the agenda, as I noticed that our speaker to follow is not connected. So I would like to turn to Mr. Beruto on behalf of the European Commission, head of B5 unit on innovation, research, competitiveness, and digitalization. As I would like to kindly ask for your views on behalf of the European Commission, on behalf of DG Energy. I think that's an intervention we're all very much been looking forward to today.
Okay, I hope you can hear me well.
Yes, thank you.
Yes. So dear members of the European Parliament, dear speakers and attendees, I am very grateful for being in this workshop where we will talk about osmotic energy. I think that workshop is very timely in today's context. As you know, the development and deployment of renewable energy sources are a strong pillar of the EU energy policy in order to achieve our goal of achieving net zero emissions by 2050. And the revised Renewable Energy Directive, which was mentioned by Mr. Grubler, and on which the Parliament and Council reached a general approach last week, aims at 40% of renewables in the final EU energy consumption by 2030. And the Commission proposed on 18th of May in its REPowerEU plan to raise this ambition to 45% so that the EU cuts its dependence on Russian fossil fuels well before 2030. And to achieve this target, we proposed new legislation and recommendations for faster permitting on renewables. And we also proposed to scale up and speed up renewable energy in every sector. For example, the Commission proposed to at least double the solar photovoltaic capacity by 2025 and install 600 gigawatt by 2030. That's a huge increase. We also put forward a target of 10 million tons of domestic renewable hydrogen production and 10 million tons of imports by 2030 to replace fossil fuels in hard to decarbonize sectors. These targets and the many others that form the REPowerEU plan will put us on track not only to cut our energy imports from Russia, but also to meet our decarbonization goal by 2050. However, we know that while the 2030 targets can be met with existing technologies, the net zero emissions by 2050 requires developing new clean energy solution. And I think that was very well explained by the MEPs. The International Energy Agency has shown that almost half of the reductions that we need in 2050 will come from technologies that are currently only at the demonstration or prototype phase. So we need to go faster. And this is why I'm so interested in this workshop to hear about osmotic energy. I find particularly interesting that unlike wind or solar energy, which by nature are intermittent, osmotic energy can offer a permanent or continuous supply of renewable electricity, this is also a form of energy that could potentially offer growth and jobs in Europe. That said, I think it is clear that, like for any new clean energy technology, osmotic energy needs EU support, and that I fully agree with Maria Grazia Carvalho. I think and this is why we have the Horizon Europe program, and I would like to thank her very much also for all her efforts to promote research and innovation at the European Parliament. I think that's very welcome. In the Horizon Europe program, which is the successor of Horizon 2020, there is more than 7 billion euro that have been earmarked between 2021 and 2027 to advance research and innovation in clean energy technologies. In addition, with a budget of 10 billion euro, the European Innovation Council supports game-changing innovations throughout the whole life cycle, from early stage research to proof of concept, technology transfer, and the financing and scale up of startups and SMEs. Like it was said in introduction, the scale up phase is particularly important. In the EU, in our competitiveness progress report, we've shown that we are front runner when it comes to clean energy research. We host, for example, a quarter of the top 100 companies in high value patents in clean energy over the last 5 years, and we also lead when it comes to high-value inventions in renewables and energy efficiency. However, our climate tech startups in the energy field still trail their counterparts in their ability to scale, and the total investments in those still range far behind the US, for example. And this is challenging for the EU. This is challenging the EU from reaping the competitiveness benefits of EU innovation. And this is sometimes leading promising ventures to move to the US or to Asia to reach scale. And that is why it is important to exploit all the EU instruments that are available to support innovators for moving from the lab to the market. And I mentioned the European Innovation Council, which is one instrument, but there is also the Energy public-private partnership, which is interesting. There is also the Innovation Fund. There is InvestEU, of course, which can help innovators. And I hope that the clean energy innovators who are attending this workshop will be able to benefit from these sources of funding. And these instruments will help them accelerate their activities because we need them. We need them to achieve our 2050 decarbonization goal. Thank you.
Thank you very much, Mr. Beruto, for stepping in, both literally with regards to your intervention and this sequence change, but also metaphorically for presenting us with the great work and the key vision of the European Commission, mentioning all these opportunities, but also calling for EU support for osmotic energy, and specifically quoting moving from the lab to the market, as was underlined within your intervention. I think that's a very important key message coming out as a takeaway already of this event. I think that at this stage, I'd like to let our audience know that due to unforeseen circumstances, Mr. Pires will not be available to join this event today. So we'll be moving with Mr. Nicolas Weze, co-founder and CEO of Sweets Energy, for his intervention. Thank you very much.
Thank you very much. I have 2 slides. I don't know if... thank you very much first for hosting this workshop today. It's very exciting for a company like Sweets Energy to be here today to tell you more about the potential of osmotic power and what it can bring to Europe. Yeah, I can start. Okay. So just to introduce Sweets Energy, so we're a French company. We are based in Brittany. We started activity 5 years ago, and we have about 25 engineers working in Rennes to develop the new generation of osmotic power generators that I'm going to present. We are funded by deep tech investors, Europeans, but also by industry partners, Compagnie Nationale du Rhône, who I think will present also today, and French utility EDF. We've also been supported by a French agency and in Europe through different programs. And I think we are now, after like 4 years of research, we started a year ago scaling up our technology to make it industrial. So I think everybody here understands osmotic power is basically this energy that generates naturally when fresh water meets seawater, right? And we think that this is the next generation of energy source to produce electricity and green hydrogen. And it basically matches or checks all boxes. It's obviously zero emission. It's permanent, unlike wind or solar, etc., as we can have water flowing 24 hours a day, right? And so we can capture osmotic power all the time, which I think is a critical and an important factor of this energy. It's domestic energy. We do not need any feedstock to other than seawater and fresh water to make it work. And it's massively available, and so far it's been completely untapped, not used, right? So it's a massive opportunity in Europe and at global scale. It's been like 75 years that academics, industrials have been trying to harvest this energy and developing different technologies. All of them, or at least most of them, are membrane technologies. And it worked, but so far the issue that it was not cost competitive, right? Because the membranes used at low power density or low efficiency, and they were very expensive. And so basically the cost of the existing technologies was way too high to make osmotic power really a competitive solution. We in Switch Energy, we took advantage of recent breakthrough in nanotechnologies. So we are really using science developed less than 10 years ago in French laboratories and to develop new membranes, nanoscale membranes. So we changed basically the scale, and so which allows to generate inner membranes much higher currents. Just, I will try to make it simple, but basically the concept is that you have fresh water stream on one side of the membrane, seawater on the other side. So there is a salinity gradient, and so ion circulates in the membrane. The fact that we change the scale, that we are now nanometric scale membranes, makes that we can have much more ion circulating much faster, thus generating higher current. And the particular properties of our membranes allows for good selectivity of the ions. So I'm not going to elaborate too much on science, but this is a real breakthrough coming from a French lab, and I think Alessandro Siria, Professor Siria, will probably elaborate much more on it later. The other important feature of our membrane, and they use biosourced materials, so low cost, massively available biosourced materials, which was also an objective of the company to have a solution that is completely, I would say, completely clean. You can maybe go to slide, not this, yeah, I'm here. And so this is patented technology. Our technology is called iNOD. It stands for Ionic Nano-Osmotic Diffusion. And so it allows to unlock the potential of osmotic power. Next slide. And for us, the key, we love science, we do science, this is our background, but what we want to do is to bring fast a solution to use osmotic power, and which means that we must be competitive. It has to be a competitive solution compared to other energy solutions. And so we are developing our technology to reach a cost of energy, what we call LCOE, that is comparable, that is competitive with other technologies. So on the next slide, you have kind of an illustration of what an osmotic power plant will be. So by definition, if you want to use natural osmotic power, it has to be at the river mouth when fresh water meets seawater, river water and seawater meet. But there are other setups when you can have salinity gradient. I will get back to that later. Now, in a river mouth, you can imagine this type of installation. You know, here the two, this mock-up basically represents a total capacity of 50 megawatt power. that could be installed. And basically, you take a stream of fresh water from the river, seawater from the sea, that goes into the system when you have stacks. It's a very smooth type of energy. There is no noise, there is no smoke, there is no big mechanics. There is no pressure applied on the membranes. It's really going smoothly into the system. And then the two streams of water mix, and they are discharged in the river mouth, which is exactly what happens naturally, right? So we are not taking water out of the river. We are just using it, and then we discharge it back to the river mouth. So the potential is huge. This is the next slide. At global scale, it is estimated that there are about 30,000 terawatt-hours of osmotic power that is generated every year. Just to put that in perspective, it's more than electricity demand on Earth, right? Electricity demand at global level is about 25,000 terawatt-hours, right? So it's massive, untapped. Now, we are not going to use all of that. The consensus is that, we could produce at minimum 2,000 terawatt-hour of energy, right, from osmotic power, which is probably equivalent to what wind and solar do together today at global scale. This is just for deltas and estuaries. It would represent about 1.5 gigaton per year of CO2 emission avoidance, right? So this is massive, right? We have wind, we have solar, we have hydro. We think it could be the fourth pillar of the energy transition toward renewables. Now, this is just for deltas and estuaries. There are other setups, other way to generate or to have access to salinity gradient, like a water treatment plant, we are working in Switch Energy in ways to convert waste heat into salinity gradient. So it's another technological step that we're working on. But if we succeed in doing that, we could basically triple the size of the opportunity. So you see it's a massive play. It can have a massive impact in terms of energy generation and greenhouse gas emission avoidance. For Europe, basically from deltas and estuaries, there are about 50 gigawatts of capacity to install from deltas and estuaries in countries by the sea, which would represent 400 terawatt-hour per year. One of the beauties here, again, is that it is baseload energy, right? Pilotable energy. You can produce, basically, capacity factor is about 85 to 90%, right? Similar to a real baseload type of power. If you take other markets, so that I just mentioned, waste heat, wastewater, etc., we could probably triple this energy generation in Europe. So we have here the opportunity to participate, to accelerate the energy transition in the EU. And in Switch Energy, we are very focusing and dedicated in making this available fast. We think that energy transition cannot wait. I think we all agree here. And so our goal is to make this technology available large scale in 2024. So it's 2 years from now, right? Before that, a first pilot plant that will be installed in the Rhône River mouth in the south of France. And you mentioned before that we are collaborating with EDF, but we are also collaborating with Compagnie Nationale du Rhône, to develop the first osmotic pilot station using our technology and to go live, to commission it by the end of next year, right? So it's tomorrow, right? And we think it's important that to accelerate and to make this thing available fast. And so this is actually our first collaboration with Compagnie Nationale du Rhône, and Frédéric Stork, I think, will present a bit later. We also, as you mentioned before, entered into an agreement with EDF a few weeks ago to deploy at large scale in France and abroad osmotic power. And obviously, we are having discussion with many other hydropower utilities who usually know well osmotic power to develop at global scale. We are working with other companies like Veolia or Solvay for other markets that I mentioned before. The idea is that we are doing all these things in parallel, developing, upscaling the technology, but also preparing all the all the projects, identifying, because, you know, it takes time, it's infrastructure, we need to work on regulation, et cetera, et cetera. So we're doing all these things in parallel so that we can become a true solution very fast. I'm going to conclude just a few words. So blue osmotic energy, as you understand, could be a massive option for energy transition. It's not used yet. Still, it's a massive potential. And with our technology, we think that we can accelerate its deployment and bring something available full scale in 2024, which is tomorrow. And I think one point that is important for us too is that we are here to develop a new industry, right? Creating job, developing industry in France and in Europe. We see that most renewable industry is out of Europe now. We think that here we have the opportunity to really create a new sector and to do it from here. And I think the current situation obviously pushes us and obliges us to work that direction. So we used to say that switch energy, or we say that switch energy is a deep tech, a climate tech type of company, and it's very it's nice. But at the end of the day, we are here to build a global leader in osmotic power and to create a real industry, working with the main actors in Europe, with a global reach, right? Because obviously, osmotic power is available everywhere on Earth. Thank you very much.
Thank you very much, Mr. José. As I noticed that your intervention has been warmly welcomed by attendees in the room and speakers in the room. I would like to thank you once again for driving change, I would dare to say, as it has been very insightful hearing from you on behalf of Switch Energy. And indeed, tomorrow comes today. And as Mr. José mentioned, Osmotic Energy is the next generation of energy source, which is ticking all the boxes when it comes to zero emissions, the provision of clean and permanent electricity, but also green hydrogen. So therefore, rendering EU able to accelerate energy transition, but also meet our ambitious targets, of course, referring to the European Green Deal, but also play a key leadership role in the global context. So thank you very much once again. And seamlessly, I would like to introduce you to our next speaker, that is Mr. Alessandro Siria, a researcher at CNRS, which is France's National Scientific Research Center. So Mr. Siria, the floor is yours. Thank you for joining us today.
Thank you very much. Thank you all. So I will share now my screen and I prepare some PowerPoint for you. So give me a second and it's gonna be. You should. Okay, should be. Sorry, try to see if do you see my screen, the presentation, or it's not?
No, we cannot see Alessandro, but if you want, I can share it for you.
Okay, that was, if it's the version, the new version that I sent after the problem solved with the compression, or it's the first version?
I think I have the correct version. I will try to put it on the screen and you tell me.
Okay, thank you very much. Yeah, perfect. Thank you very much. So, yeah, this is a bit more a presentation about the scientific background that is behind this osmotic energy. So we are a laboratory in physics at the École Normale Supérieure, and we are part of the Centre National for the Research Scientifique here in France. So to understand osmotic energy and the origin of osmotic energy, we have to talk and to understand a bit more what are the properties of fluid at the real molecular scale. This is more generally the field of nanofluidics that is the core of our research interest in our group. This group has been very generously funded by the European Research Council over the last 10 years through the Advanced Grant Program, Starting Grant Program, and more recently also with the Proof of Concept. So we have been able, thanks to this funding, to move from our fundamental research to more sort of an application, and of course, thanks to our collaboration with our partners, and of course with Switch Energy. So you can switch slide. So just to understand as we start, it's going to be very, very short and fast, but I will say that if we want to understand osmotic energy, we have to understand how fluid behaves at a small scale. But even before that, we say that the behavior of fluids can be, we know that the behavior of fluids can be described using a very old equation that is this, the Navier-Stokes equation, that has been introduced almost 200 years ago and still is used today, and is able to describe and predict somehow the behavior of fluid from in a very different range scale, going from planetary scale to human size scale, but is even able to understand what is happening at a cellular or let's say very small scale, and it has allowed us to take benefit and to develop new tools that is now, for example, used for in microfluidics in the lab. But as you can see in the next slide, nature show us that there is a real interest to go beyond this very simple and classical point of view, and go at a scale that is the scale of comparable to the molecule of the liquids, because that is what nature show us, is that going beyond Navier-Stokes, going in the region where there is new science, it is possible to develop new functionalities and new devices with exceptional properties, for example, in terms of filtration or even in terms of ionic conversion. So there is a clear now understanding that new properties can be obtained and observed at the nanoscale, and then we have new assets to play. But it's not a simple task, because to go down at this scale, a lot of hard work in the sense of lab tech has to be developed. And this, for example, what has been done and what are currently doing, for example, in UK with the Graphene National Center, or even in the US with this new mid-water initiative, where they are working very hard to build new devices using nanoscale materials in order to be able to treat water, to clean water, but also, as we are interested in now, is also to convert the energy and goes and in a certain way, like be able to convert the osmotic energy to electric energy. But so this the beginning, but we are already know, and what we have done in the last years, that we have already shown that is not only an idea, and it's not only something that can be, I mean, sort of a dream, that we can use these properties. And as we can, in the next slide, we can see is that we, in our group, we can switch the slides, please. Yeah. So we have seen that there are indeed fundamental breakthrough that can be done when we work at this scale. So it is possible, for example, and it is what we have been interested in, that we have worked in the last years, that it has been possible to convert this osmotic energy with a very high efficiency using novel class of nanoscale material. We started at the beginning with the nanotubes, and we now move to other kind of material. But it's not only limited to this osmotic energy. This is true more in general. So it has been possible, for example, to observe also non-classical behavior for fluid at the nanoscale. And we have, for example, observed a sort of a quantum enhancement of the water permeability in carbon material, graphene, for example, that is a sort of miracle material that is very, very known, of course, where we observe permeability that exceed by order of magnitude what we can predict. And even more recently, we have been able to show that thanks to these properties, it's even possible to create, or to hope and to create a sort of a new electronics, not based on electrons like standard, but based on ions. So basically, it's trying to mimicking or recreating in an artificial point of view what what is currently done, for example, by our brain. So from a fundamental point of view, it is clear that fluids at the nanoscale can give us new opportunities to understand and to solve main problems. But also, nanofluidics is not a field that is only important from a fundamental point of view, but it's also a field where the path from fundamental research and innovation and application is quite short. So in the next slide, please. For example, we have seen, and that is what we have done in the years, is that it is a direct and short path between fundamental research in the lab and application. For example, of course, this is true in the case of blue energy, that is this fully renewable source of energy that is now a level of maturity that has been presented by Nicolas before, how Switch has been able to take what has been our, let's say, our result in the lab on a very, very small scale, and is now move it and transform this finding on a lab scale experiment to even a dream and hope of a real scale power plant. But beyond blue energy, it is also true in case of water and liquid treatment. For example, it is possible now to imagine, to dream, and to create new kind of filter that are able to depollute water very efficiently. And it is, for example, what has been now the core of business of a startup company that's been created in connection with our lab that is Alter, that is, however, based in the US. But it's not only related to only this. Nanofluids can also give input and can give solution not only to this, to more related water-related content, but also to other kind of application. For example, in the case of nanoscale printing, so it's possible now, thanks to another company that is Homing that we have created, for example, to use nanofluidic functionalities to create a novel class of three-dimensional printing machines where we can now, for example, change the size of electronic connections. And finally, we also observe, and this is what we are doing with the company that is called UPI, is that it's also possible to generalize this point of view and create a novel class of instruments. So it's clear that nanofluidics can give us a real short path to innovation to solve our problems. But if we now come back to the main problem and what is the osmotic energy, that is the core, the subject of the next slide, is that we can try to, we can ask ourselves from a scientific point of view, what is this osmotic energy? So Nicolas presented very efficiently before, is that basically osmotic energy is the energy that comes when you mix salty water and fresh water. And as we know from our everyday life, we know that mixing is a spontaneous phenomenon in the sense that everyone knows that when you put salt in water, salt starts to dissolve and to move everywhere around. So it means this is a spontaneous phenomenon. That means that there is some hidden energy that is, say, this osmotic energy that is inside this mixing. And if there is this hidden energy, it means that we can also extract it and convert it. Where does it come, this energy? It's basically the energy of the disorder. So salt prefer to be surrounded by water and to be in a relatively good order device, and so configuration. So it prefer to move from a situation where all the salt is one side and no salt is from the other, to a situation where salt is everywhere. So this is the energy that we want to convert from, let's say, from entropy, so from disorder to electricity at the end. And then we can ask, what is the maximum energy available? So we can, for a very simple thermodynamic discussion, we can extract this sort of density energy that we can have. And this I just, of course, not entering into the details, but it's this value that we always have in mind, that is the maximum theoretical energy available, or energy density, is the order of 1 kilowatt hour per cubic meter of water. So to understand, this value is still very low. If you compare, for example, of the energy density that is in oil or fossil fuel, that is 10,000 times lower than this value. But what makes osmotic energy extremely interesting is the amount of water and salty water and fresh water that we can use. We of course we are missing in energy density, but we are having so much amount of available material that this can translate in a very large value of potential energy that we can use worldwide. So Nicola explained that and presented that is this value that is exceeding the 20,000 terawatt hour per year. So this, just also to put it in a point of view of what to understand, this is more than 2,000 nuclear reactors. So it is totally clean, as we have said, it is not intermittent, and the value is more than 2,000 reactors. And as we can know, and we can see, it is less problematic to develop and completely renewable energy as osmotic energy compared to 2,000 nuclear reactors. So this energy has been, we know the source of energy, it's there, and we know it from, as I said, from more than 70 years, and we know that this value are extremely large. So the question was why we are not being able to do it and to really work and to convert and use this energy so far. The reason was that the efficiency of the standard of state-of-the-art membranes to convert was extremely low. So not only from an economical point of view, but even just from the ability to convert this energy. It was not fast enough. But things has changed in 10 years ago. That was what we say. And you can see in the next slide, please. So what happened 10 years ago is that we realized that nanomaterial can change the game completely. So this is the miracle of the nanomaterial that we have observed more than 10 years ago. So novel material that are particular because they exhibit, for example, an enhanced surface activity to water, so they are really reactive to the water, can boost this energy conversion. We started this work in 2012 when we observed this highly efficient way to convert osmotic energy using nanotubes. And after that, other groups worldwide worked hard to reproduce or replicate this result. And for example, it has been observed also with other kind of nanomaterial that can be nanopores made of sort of graphene families materials. So this is clearly something that has been, because we confirmed. So we know that it's possible to create and to convert energy very efficiently using these materials. The problem is that if we want to go from a lab to an industry, we cannot use the material like here we are using in the lab. We need to scale up. So we need to create and to use material that are not only good and nice for the lab application, but can be scaled up to real size membranes. And this is what Switch Energy has been able to do, and it has been probably the only company that has been able to do this work, is that to be able to identify the materials that from a scientific point of view were the best to convert this energy, and to realize which one could be moved from a small scale to a large scale. So this is the big step that has been done in the last 10 years, in particular in the last 5 years, was to be able to screen and find the new material that couple these two strong requirements that are needed. So very good from a scientific point of view, so very efficient in terms of energy conversion, but also easy to scale up. So this is what makes us possible to use to convert osmotic energy. But if you go now also a bit further, is that what we can do with osmotic energy. Of course, it is a source of energy, so we can use it immediately as a source or as a sort of electricity power plant. But we can also go further and imagine to use osmotic energy for other applications in a certain way. And as you can see in the next slide, one of the applications that is now extremely interesting and has to be looked is that, for example, the use of osmotic energy for production of hydrogen, and in a sort of way that the use of a green hydrogen. So clean way to produce liquid hydrogen. One way that we can imagine is that, for example, to couple directly the source of energy that is basically the power plant from Switch to a standard electrolyzer setup where we need basically electricity to separate hydrogen and oxygen from water. And the big interest of this material is that Switch Energy is using and is producing energy exactly at the place where we have the main material that is used to create the hydrogen. So where we have water. So that is the interest, is that it can be we can imagine to couple now a device or a sort of a plan where we have energy production and hydrogen production in the same site. So this is something that can make the system much more efficient. And of course, this can be also delocalized, as we said before. There is no, we can basically have no limit as soon as we have fresh water and salty water. So every series of letters of a river can be imagined as a place also to create energy and to create hydrogen. But also, this is just the sort of the first step. But as we say, science cannot stop, and science has to keep improving and propose new solutions. And that is also what we can imagine and we can now to think is that to create a sort of a novel class of hydrogen production devices. And this is on the last slide, that is the next one. So it's basically the idea of creating new electrolyzer setup, and in this sense it can be done only using, for example, tailor membrane made, for example, by the I-Node technology of switch, where we modify even more the membrane by using advanced catalysis technology, for example, like the one that is based on single atom catalysis. And we can imagine to create now membranes where not only we can use to not only produce energy, so electric energy, but also to at the same time in parallel to create and to realize electrolysis. So in this sense, it's going to be even sort of a faster way to create, in the sense that it's going to be a single stack of membrane that is going to be able to produce energy and at the same time to separate hydrogen and oxygen. So this is the real potential of osmotic energy also for electric hydrogen. And now I can conclude with the last slide, just to remember what I wanted to say is that basically, I would say that blue energy is a fully renewable source of energy that is based on a phenomenon that we know since 70 years, but only now it's possible to use it because we have been able, thanks to what have been done in the last year, to move the fundamental findings on the nanoscale material to large scale membrane. So it is the moment where we can push the production of energy with osmotic energy, but also it's time that we also think of what we can do next. So it's not only what we can do now with osmotic energy, but also what we can do further. And that is, for example, what I think it's a really important topic that we have to discuss is that we can use this advanced nanofluidic functionalities that we are currently using to boost osmotic energy, but also to boost the green hydrogen production. And with this, I really thank you for the attention, and it's been a really pleasure to discuss with all of you.
Thank you very much, Mr. Syria, for this informative presentation, drawing inspiration from nature, enhancing our understanding, and all in all pushing for innovation and well-informed science-based policy making, which has also been at the cornerstone of the vision for the European Parliament Intergroup as well. And indeed, it's of significant importance to link the innovation with the sustainability agenda. So thank you very much once again for your remarks, as I think that it's a very strong message from lab to industry, which comes back as a key recurring theme today in the context of the need to scale up. So thank you very much. Moving on into today's agenda, I see that Mr. Carlos Moraes Pires is connected. So I wanted to explore if you would like to take the floor now, perhaps.
I can take briefly the floor if you allow me. Sorry, I'm putting my camera. Can you see me?
Yes, very well.
Apologies. Actually, today it's a very nice day for us and for Commissioner Maria Gabriel. She's in Strasbourg, not so far from you, I guess, because we are launching the new European Innovation Agenda, and our Commissioner will very soon talk about it and present it today, which is something which I think it's very relevant also for the community that works on research related with hydrogen and in general. So I invite you strongly to have a look at this initiative, which together with the European Education Area and the European Research Area are, let's say, framing documents for the portfolio of Commissioner Gabriel. So, but thank you very much for the invitation. The Commissioner could not participate, but I think I would use very little of your time to say a few words about actually the relevance and the timeliness of talking about hydrogen in general and of research and innovation that is very important in the area of energy and in the transition for more sustainable sources of energy. So this, I mean, I'm not going to repeat things that people are saying, and our commissioner is very clear when she says that we have to link this with an opportunity to innovate. So the transition to a sustainable planet is an opportunity to innovate. So from our portfolio perspective, this means more investments and more actually a logic of using, let's say, technology, innovation, and so on to bring this this to the forefront of what are the investments from member states, regions, and at European level. So, in short, lately the latest news, I think, that are of your interest, and I would like to draw your attention to that, is that given the geopolitical situations, we have been discussing the so-called the package of repowering the EU. So under this acronym, I would say you could interpret this as a sort of acceleration package of the objectives of 50 Fit for 55 packages that have been, let's say, high in the political agenda of Europe. So a transition that has many targets from, let's say, from all the perspectives of the value chain of production of energy, from real production to storage, to infrastructures, to stock energy and to use it, and to downstream industries like transport and so on. So this Repower EU is something that member states ask the Commission to put forward, and in within this package, you will find one section, one part dedicated to accelerating the transition or use of hydrogen with all its potential in terms of energy production and energy balancing infrastructure and storage. So this, from, let's say, this package of acceleration, I highlight one particular aspect of the portfolio of Commissioner Gabriel, which is related with the concept or the implementation of hydrogen valleys. And here I would say that the first thing that is very tangible is the message of not only intention, political intention, but also investments of Horizon Europe to accelerate the transition through doubling, which is a target, doubling the number of hydrogen valleys in Europe. And this is a target, easy to read, easy to understand in terms of political terms, and was very well received by governments. And it was presented, as I said, on the 18th of May, just a couple of months ago. Now we are in a phase, internal discussions within the Commission on how to make this happen in practice. And this means and by practice, I mean two levels. One is how can we now bring together the different communities, those that are already deploying 20-ish hydrogen valleys today, how to double them, what is the roadmap to do it, and how the financing will be done in terms of putting on the ground this idea. But just one other aspect is that by hydrogen valleys, we would like to see, Commissioner Gabriel would like to see a strong emphasis on research and innovation, touching the value chain as a whole. So from production to really the downstream usage of hydrogen. We have visited, Commissioner have visited several of these valleys in Europe. She will continue doing so. We are working on this roadmap, and we expect during September and October to be able to bring together around the tables in plural all stakeholders that would like to take part of this journey, which I think it's very attractive from a research and innovation perspective. So we plan after the summer a number of key events that bring this. Now, the interaction I had with the people working on Osmotic, which is really of a lot raises personally and to our commissioner a lot of interest and even curiosity, is also, if I understand well, some aspects of maturity of certain technologies. I was able still to listen to some of the things that were said by the previous speaker, and I apologize for arriving late, but there are some emergencies around. Is that the fact that there are, I would say that there is in this acceleration the importance to highlight the readiness to mature and to bring to really to implementation what we have in terms of technologies. But there is also something that is very relevant for our commissioner, is the medium to long term and the preposition for introducing innovation along the way in the coming, I would say, decades. So because if we think about accelerating and putting pressure on all of us to bring quicker to the market solutions, and this concept of value chains and values that can demonstrate that all value chain can evolve together. It's also important that we guarantee that this innovation is also looking beyond 5 years. So there is really a long-term perspective of the type of innovations that you need in these markets. And so this is a little bit the message. So there is the Repower EU that brings a context which is also influenced by the geopolitical context of more autonomy in terms of what Europe can do in terms of production and storage of energy. So this acceleration is an important thing, but also pragmatism in the sense of using what the knowledge we have to go quicker to implement solutions. And the second one is that we have the mechanisms, Horizon Europe. We are in a key phase of redefining the programs for 23, 24 and beyond 24, 25, 26 and 27. So there are perspectives of strategic roadmaps that need to be prepared now in this new context. And so I would conclude inviting all of you to pay attention, and I remain available to be involved in the events we plan in the second half of this year, September, October, to discuss the roadmap of this. I think it's a very ambitious target of doubling hydrogen valleys in Europe. And with this, I close, and if there are any questions I can help at this stage, I'm happy to do so. And I wish you, of course, a very nice and fruitful meeting. Thank you very much.
Thank you very much, Mr. Carlos Moraes Pires. It's been very much appreciated hearing from you on behalf of Commissioner Gabriel. So thank you very much for underlining the relevance, but also timeliness of this discussion, mentioning the key role of research and innovation, Repower EU, but also the relevant mechanisms in place, as it's indeed crucial to boost sustainable and renewable energy sources with great untapped potential, as mentioned during your intervention. So on this note, our next speaker is Mr. Frederick Stork, Director of Energy Transition and Innovation at CNR at the Compagnie Nationale du Rhône. And on this note, I'm delighted to provide you the floor. Just as I'm slightly concerned about time constraints, this event takes place within a busy European Parliament plenary week in Strasbourg. I would like to kindly ask speakers to follow to deliver their messages in the allocated time frame, if possible, in a slightly shorter period of time as well. So, Mr. Stork, the floor is yours.
Thank you very much. Thank you very much for your invitation. Is it possible to have the slides, please? Thank you very much. So I would like to tell you a few words about CNR. We are the first energy utility partner of Switch Energy. And what about a few words about our interest in osmotic production. Next slide, please. So who we are the river concessionaire of the Rhone River with 3 missions: generate electricity, develop the river navigation, but also irrigate agricultural land. So our corporate purpose is the Rhone for origin, the territories for partners, and renewable energies for the future. Next slide, please. We are the first French producer of 100% renewable energy. We are a historical producer of hydroelectricity, but we have been diversifying our energy mix since the years 2000, especially in wind and sun. We are also an actor of the energy transition alongside the territories. As you may know, we have 183 collectivities as shareholders. So it's the reason we are participating in the construction of tomorrow's energy landscape at this local level, but also in the framework of national and European guidelines. Our particularity is that we manage exclusively renewable energy, and I would say weather energies. Next slide, please. So our production assets today, of course, you have the Rhone River that you well know, with 19 dams and 20 hydroelectric power stations. And our diversification in wind and solar, you can see the map. So we have something like 55 wind farms and 33 photovoltaic plants for a global capacity of 4 gigawatts. And we plan to reach 6 gigawatt capacity in 2030 by accelerating our development. So it's 100% variable, weather-related electricity production. We don't have any storage capacity, and that's one of the first reasons of our interest in the osmotic electricity production. Next slide, please. So our interest of osmosis is that it's a means of electricity generation that is potentially meeting our 6 strategic ambition for 2030. The first of all of these is develop the Rhone and its users in a responsible manner. As a concessionaire of the Rhone River, we have the mission to develop the Rhone from the energy point of view. And of course, if the hydroelectricity part has been done several years before, it still remains possibilities, and it's the reason why we have looked at osmotic production for many years, but we didn't find any technology that was, as Nicolas explained, that was sufficiently efficient to perform this. Second ambition is to accelerate the production of renewable electricity. So of course, on the Rhone itself, a little bit, with a new hydroelectric power plant, but also thanks to wind and solar. Third strategic ambition is develop the storage and flexibility of renewable electricity. This is the most important point, we believe, and we want to reach it in 2030. The main reason is that, of course, it's necessary to develop renewable electricity, especially wind and solar, but the time has come to develop flexibility and storage means in order to get the most value as possible out of those energies. Fourth strategic ambition is increase the company's performance. And as an actor of the wholesale market of electricity, we are looking to different ways to get value out of these energies, and especially being able to produce when there is a strong demand thanks to flexibility and storage. It will be very interesting. We are also dedicating many resources to hydrogen production, transforming renewables into hydrogen in order to get another product from electricity. Fifth strategic ambition is be the innovative energy company of the future for the ecological transition. It means that we are ready, we work with different startups in order to get new technologies to achieve those targets, and especially startups that are ready to go to the scale, the industrial scale, like Switch Energy. And finally, last but not least, support territories in meeting the climate challenge. In fact, addressing new energies like osmotic energy is also a way to help the territories connected to the Rhone to get new revenues out of the energy that they have on their territories. Next slide, please. So the synergies that we seek between the Rhone, wind power, solar power, and osmosis. First of all, as a concessionaire of the Rhone River and player in the territories, the aim is to complete the energy recovery of the Rhone Valley by exploiting the big osmotic potential to its maximum. Second point is to contribute to the industrial development of the French osmosis sector and develop electricity production with low environmental impact. As an energy provider, we want to contribute to accelerating the development of renewable energies to meet the objectives of the Paris Agreement. We want also to develop complementary electricity production that will compensate for the decrease in the flow of the Rhone due to climate change. We have an estimation of -10 to -40% of the flow discharges till the end of the century. So developing the osmotic energy is a means to compensate this decrease. We also want to develop this complementary production that will not penalize existing hydroelectric production. That's very important because the Rhone was designed, the different hydro power plants were designed in order to get value out of the river at its maximum point. And we have had some tentatives to develop some different ways of getting energy out of the river, but they had a strong impact on the hydro itself. The big advantage of osmosis is that it won't change the water levels, it won't change the water discharges. So it's a new way to get energy without penalizing what's already existing. And last but not least, we also look for a continuous and controllable way of producing energy that will help balancing the hydro, its run of the river on the Rhone, of course, but also wind and solar production. We need something controllable in order to operate the best way the Rhone River, but also wind and solar. And finally, as a specialist in river hydraulics, we want to provide our expertise to Switch Energy for the development of an industrial demonstrator. And Nicolas told us that next year we will get from the lab to the field in the Rhone estuary, and then we want to go with them to the market in 2024 in order to get the potential out of the Rhone, which is the biggest in France, and to give you some figures comparing the potential of the osmotic energy on the Rhone River. It's something like 1/4 of the global hydropower production. It means between 3 and 4 terawatt-hours per year. Thank you very much for your attention.
Thank you very much, Mr. Stork, for presenting us the work and the interest of CNR. It's been very insightful hearing from you on CNR's vision when it comes to osmosis as a key means of electricity generation. So our last but not least in today's list of excellent speakers in Strasbourg, but also online, is Dr. Frank Neumann, Director for Infrastructure, Environment and Innovation. So with no further ado, Dr. Neumann, the floor is yours.
Thank you. Last but not least,
yes.
Thank you very much, Ilias. Also, I would like to thank Ms. Maria de Gracia Carvalho, Member of the European Parliament, as well as Mr. Christopher Grietler, Member of the European Parliament, for inviting me here today and also for greatly advancing the case for osmotic energy by introducing the amendments to the Renewable Energy Directive. I think that's very important for the whole sector, and that this commitment is greatly appreciated. Yeah, my name is Frank Newman from IMIU. We are a non-profit based in Amsterdam and Brussels, and our core tasks are, maybe the next slide, our development of demonstration projects that show that it's possible to combine economic development with climate mitigation and sustainability, as well as to advise in cases where there's a conflict between infrastructure and biodiversity. Next slide. Yeah, I will not go into some of the slides because some of the aspects have already been mentioned by prior speakers. So maybe the next slide. And the next one. Yes, this one is important because there are benefits that were not mentioned before of osmotic energy. One is that it's not just technology, it's actually a way of power generation which, like a chameleon, fits to the infrastructural environment. So it means that the buildings are very discrete and integrated in the landscape. I will give an example of that. But this is a very important factor also, that the way the construction and operation and maintenance is done is benefiting the local economy a lot. It provides employment, and also local SMEs can be used for operation and maintenance. And the other item is also important. It's not just electricity generation, actually, because there are developers which are now already TRL 7 or 8, which I will give an example of, that are not only focusing to electricity production where the river meets the sea, but also are generating power from brine from an industry, for example, the salt industry. So this is not only a renewable power generation, but also a kind of circular economy promoting environmental improvement. The next slide. And I'm also speaking out of experience for an international network, energy from salinity gradient power, which is the same osmotic energy, already since 2012 working on the upscaling of lab inventions towards demonstration projects and then towards the market, because that is not an easy trajectory. Also saying that to new entrants in the market, it's not easy to go from the lab where you have maybe 20 centimeters of membrane to go to a very large installation where there's, for example, 100,000 or 200,000 square meters of membrane running very large volumes of water. And then, of course, in the last step, also to make it commercially viable to go to the market. That's what we are doing in cooperating in this INES Osmotic Energy Network, which is not only European, but also international. So then I would like to go to the next slide. Here you see some of the partners. Some of the partners are also here. So then maybe we can go to the next slide. As Mr. Beruto mentioned, there were Horizon funds and also other type of European grants have been used for other entrants of osmotic energy, notably developers and companies in Denmark, in the Netherlands and in Italy. And over the past years, they've received over 80 million euro from Horizon funds, EIC Innovation Council, and other type of grants. Here you see some of the logos of the projects. So maybe go to the next slide. Yes, in this slide, I'm not sure if it's very well visible, but it's important to look at this slide a little bit longer and also take a closer look, because here you're looking at, this is not a rendered picture, but a real picture. And here you're looking at the first demonstration plant worldwide, an R&D plant where actually power is generated from the Wadden Sea on one hand, which you see below, and the fresh water of the IJsselmeer, which is above. And the power plant where actually the electricity is generated, you see it's the blue building. And here you see already how challenging it can be to adapt to the infrastructure, because we are looking at the main sea defense in the north of the Netherlands. I don't know if you know this sea defense, the Afsluitdijk. And also it has a lot of regulation and permitting protection. So for example, it was not possible to drill or to make deep holes in the ground for the construction. So a lot of the piping is just lying, actually is fortified on the sea defense, and it doesn't affect it. And here in this site also a lot of experience was gained to mitigate the environmental and ecological effects of the of this osmotic energy production. So a lot of mitigation measures have been developed here to make the ecological impact benign. Maybe the next slide, because besides Redstack in the Netherlands, there's also another developer in Denmark who has also gone a lot closer to commercialization. Actually, the first commercial plant is already being developed right now in Denmark and is supposed to be finished end of this year. And here, that's also very interesting because here we see how electricity production can be combined with principles of circular economy, because here the electricity is generated from, on one hand, the brine from the salt production of Nobion and Dansk salt. And on the other hand, as a fresh water, the processed water is used, which is then reused again in the process. So this is a very good example of how an integrated solution can not only provide electricity, but also save resources. So maybe the next slide. Yes, maybe then stay on this slide, because here we are looking at a picture of Italy, of course, and then at the red dot, you see the Ettore Inversa salt works, where University Palermo and their spin-off resource C's are generating electricity from, on one hand, the brine from the desalination plant, and on the other hand, from runoff waters of the salt ponds, as well as the seawater on the other hand. And yes, this project was also sponsored by quite a bit of EU money and is also now close to TRL 7 or 8 going into commercialization. So maybe the next slide, you see there was quite some support for these projects. Yes, and then maybe the next slide. 3 lessons are important, I think, to learn from these other developments where there was a good development from the lab to a demonstration site and going into real natural water. One aspect is that it's quite challenging to deal with quite large volumes of water. So, for example, that 100 or 1,000 cubic meter passes in half an hour or the whole installation. So this is quite challenging. It's not easy to go from this small lab scale to upscale to a commercial operation. That takes time also to find out the structure and a way this can be done in a business economic efficient way. But the second most important thing, and that's maybe also for the discussion of today actually, is the composition of the water. Of course, we see that water in the Rhône is not the same as water in other rivers, and we've seen in demonstration plants from this INS project is that it's very important also for example, the steps of pre-treatment of the water to have this wide response to the specific composition of the water. For example, how much clay there is in the water, or if there is more iron or less iron, what are the temperatures of the water. So yes, going from lab to demonstration site is not an easy trajectory, and it's very important to maybe also to use the inspiration of products that have come before. So this is also a little bit the message that I would like to give to the audience here. New entrants, it's very good to make opportunity of the European products that already have been completed, and also of the experiences to go from the lab to the demonstration. Yeah, and then of course, last aspect, but of course that is the same, the common issue in most developers of osmotic energy is how to make the membranes low cost and at the same time high quality. That is of course the challenge of everybody. And there's another challenge which is not mentioned here is of course to find the right locations. And that's what we're also trying to do in this INES consortium, to look for proper locations where there is, on one hand, clear and maybe good water to work with, but on the other side, also the good combination of saline and less saline water. So maybe now I'll go to the last bit of my presentation, the next slide. We are very thankful, of course, that now the osmotic energy amendments give a lot of wind in the back of the developers and innovators and the risk takers. So that is, we are very encouraging. And maybe one other point to say is that we are, of course, very happy that there is now the Repower EU plan. What is very important also for the sector is to see that right at this moment, the European developers are ahead of the other one in Asia. There was also some projects in North America which have not succeeded just because of the underestimation of the issue of this water quality. So we also maybe like to focus the attention here is to keep this advance on the other developers around the world. Maybe it's also good for European institutions and other part of European Commission to try to find sources to more, in a concerted way, develop or support measures to bring the developers to the next step. Next slide. Yeah, I think maybe for time I can skip. What is very important to mention is that from Mr. Beruto, his colleagues from DG GROW, they used out to us to make a glossy report of all the developments in Europe, and also from that report to see how the EIC structure of the programming could be better adapted to find more funding for osmotic energy. So we hope this will be a continuing successful exercise. And maybe then I have my last slide here. 26th September, during European Sustainable Energy Week, we always have a very large open meeting for everybody. So everybody here is welcome to be fully updated on the latest developments in this osmotic energy sector, hopefully a growing sector in Europe. Thank you very much.
Thank you very much, Mr. Neumann, for underlining the concrete advantages of osmotic energy, the, of course, challenges and opportunities ahead, but also highlighting the need for international and European cooperation, but also support for EU projects. This goes to say, of course, a big thanks to all speakers, and MEPs and assistants, and dear participants of today's event, either online or in Strasbourg. And unless there is a burning question from the audience, seeing none in the room, I'll just provide the floor back to hosting MEP Mr. Grudler for his key takeaways of today's discussion. As Mr. Grudler, I think the question here is, what would you like our speakers and audience to take home today? What is your reflection of today's event?
Thank you very much. And it's a real pleasure to conclude this event, of course. It was very interesting for several reasons. First, for the very first time, we are gathered all together, innovators, businessmen, and policymakers to discuss osmotic at the Parliament in Strasbourg, where we are surrounded by water. I would like to thank the entire group for this historic moment. And of course, I say to all the speakers, I need all your slides, because there's a lot of information which will be very useful for the work I do today. Then MEP Carvalho made an important point on innovation, on the need for Europe to support research and development. It will bring out new technologies in the EU and global markets. Let's embrace our leadership. Then I really appreciate this sentence from the Commission saying that we need to support the technology from the lab to the market. And I welcome the launch of the new European Innovation Agenda. What a day for energy innovation today. We learned more about the best cases studies and European projects. It made me very optimistic, I can say. I would like to thank Mr. Jose, Syria, Stork, and Dr. Neumann for the compelling presentations. Finally, we had the opportunity to hear what the market needs. We need to push today, and we need to see what we can do tomorrow all together. For example, regarding the infrastructure, your last topic. It is therefore very good that we start this discussion now. Then thank you very much, and let's go ahead.
Thank you very much, Mr. Grudler, for summing up today's discussion so very much to the point. As on behalf of the Secretariat of the European Parliament Intergroup, I'm also very much looking forward to continuing the discussion in the near future. So until then, all the best and stay safe. Thank you very much.